Today we're talking about section 3.5, which is writing and graphing equations of lines. We talked about slope in the last section. Today we're going to review some graphing. So for example 1, we're going to write equation of a line from a graph. And we're writing an equation in slope-intercept form, which as a reminder looks like y equals mx plus b, where m is your slope and b is your y-intercept, where your graph crosses the y-axis. And x is always 0 at your y-intercept, as a reminder. So in this case, if I'm going to write any sort of equation, the first thing I should always do is find my slope. Looking at my graph over here, I have 2 points that I can use, or really I can use any point on here that appears to line up nicely. And I'm going to count my rise over my run to find my slope. Since I have a graph, so here I'm moving down 1, 2, and right 1 to go from my first to my second point. So since it's down 2, it's negative 2. Right 1 is positive 1, so my slope is negative 2 over 1, or simply negative 2. So I found my m. Next I need to find my b, my y-intercept. Your y-intercept is wherever your line crosses the y-axis. It's always accompanied by the x-coordinate being 0. Here's your y-axis. In this case, the graph is crossing here at 0, 4. Since the x is 0, you know that your y-intercept is 4. So here your y-intercept is 4. And then we can write our equation. Y equals mx plus b. But we know our b is going to be negative 2. And our y-intercept is 4. You always leave x and y as variables, x and y. So simple enough. You find your slope, find your y-intercept, write your equation. The exact same 3 steps every time, except sometimes you can't use your graph to find your slope. You'll have to use your slope formula or no knowledge of parallel and perpendicular lines. Here we used our graph to find our y-intercept. Sometimes you won't have a graph to use, like our next example. Write an equation of the line passing through the point negative 1, 1 that is parallel to the line with the equation y equals 2x minus 3. First thing, as usual, is find our slope. And we're not given 2 points to find our slope with our slope formula, and we're not given a graph either. What we are given is that it's parallel to this line. So our original slope of the first line is whatever is attached to x when it's in slope-intercept form, which this is in slope-intercept form because y is by itself. So 2 is our original slope. Since our lines are parallel, our parallel lines have the same slope, so our parallel slope is going to be the same thing, 2. So we know our slope of our new line, our parallel line, is going to be 2. Now, we're not given a graph to simply identify our y-intercept, so what we have to do is use other given information. We're going to have to use this point that they give us. We know this point is an ordered pair, represented by x and y. So what we do with our slope-intercept form is we know our slope of our new line is going to be 2, so that's what we use. We also have an x and a y we can plug in. We know x is negative 1, y is positive 1. So I'm going to plug in my x and my y, and now the only variable I have is b, so I can simplify this equation and solve for my missing variable b. If I multiply 2 times negative 1, that gives me a result of negative 2. And to solve for b, I'll add 2 to both sides. So these cancel, and I have that b is 3. So again, to find your b, you plug in your slope and your point, and then solve for your variable b. And finally, the equation of our line is what we write thirdly. So we're using slope-intercept form, so y equals mx plus b. Again, you leave x and y as variables, but plug in a number for m and a number for b. We know our m, our slope, is 2, and our b, our y-intercept, is 3. So there's the equation of our line. So you found your slope of your original equation, which gave us the slope of the parallel line. They're the same. And then we plugged in slope and x and y to find for b. Let's try a perpendicular one. The exact same thing. We're given a point it's passing through, x and y, but it's perpendicular to this line. So the first thing we need to do is find our slope. Well, the slope of the line that's perpendicular is negative 2. So your original slope It's negative 2. So your perpendicular slope will be the opposite reciprocal. It's no longer negative 2, it's a positive. And instead of 2 over 1, because it needs to be a fraction, we flip it. So it's 1 over 2. So that's our new slope. We no longer use anything from the original equation. All we use is our new perpendicular slope. Next, again, we find our y-intercept, or our b. And we plug in our point and our slope. We have a point, x comma y, which is x is 2 and y is 3. So in my slope-intercept form, my y is 3, my new perpendicular slope is 1/2, my x is 2, and then I can solve for b. Simplifying, 1/2 times 2 is 1, so 3 equals 1 plus b. And I'll subtract 1 from both sides so that it cancels on the right, and I'll end up with my b being 2. So now I can write my equation in slope-intercept form, again leaving x and y as variables. So if I plug in my slope, which is 1/2, my y-intercept, which is 2. Ta-da! And for a final example, a review of graphing, one of two ways you can graph lines. For this one, number 6, this is 2x minus 3y equals 6. I'll start by the longer way, which is getting this into slope-intercept form. If I want to get this into slope-intercept form, then I need my y to be by itself. So I need to get rid of this 2x and that 3. So I'm going to get rid of the 2x first by subtracting it from both sides, because you want to get rid of the stuff with the x's first. So these cancel, and you have negative 3y equals, and you can't combine these like terms because they're not like terms. One has an x and one does not, so you leave them separate. To make it in proper form, I usually put my x's first. So my negative 2x comes first, and my positive 6 comes second. Then I need to divide both sides by negative 3 to get rid of that negative 3. So these cancel, and I'm in slope-intercept form. I have to divide both terms by negative 3. So negative 2x divided by negative 3. Well, negative 2 divided by negative 3, it's going to give me a positive, but it's a decimal. So I'm just going to leave it as a positive fraction, 2/3, with my x. And then positive 6 divided by negative 3 is negative 2. So there's my equation in slope-intercept form. To graph it, you start with your y-intercept, your b, which is negative 2, and then use your m second. The way I like to look at it is you begin with your b, and then use your m to move. So beginning with my b, my y-intercept, I go to the y-axis and plot a point at negative 2. And then I use my slope to move. It's up 2 because it's positive, and right 3 because the 3 is positive. So I'm going to move up 2 and right 3. There's my second point, and there's my line. There's a second way we can do this. It's a little bit faster, but if you're not comfortable with it, it's only an option. You don't have to do it this way if you like the first way. You can plot this by finding your intercepts, your x-intercept and your y-intercept. To find your x-intercept, you take your equation, but plug in 0 for y. So 2x minus 3 times 0 equals 6. 3 times 0 is simply 0, since it's 2x minus 0 equals 6. But since subtracting 0 really doesn't change anything, I don't need to write it. I can just write 2x equals 6 and not worry about this guy. And I'll divide both sides by 2, so my x-intercept is 3. So I can plot a point at 3 on my x-axis, which I actually already have it there. And you'll see that it's the same. For my y-intercept, plug in 0 for x. Two times 0 is 0, and 0 minus 3y doesn't really change anything, so I'm not going to worry about the 0, and I'll just write my negative 3y equals 6, and divide both sides by negative 3 to get rid of this negative 3, so these cancel, and y is negative 2. So my y-intercept is at negative 2, so I go to my y-axis and down to negative 2, and I get the same 2 points as before, so I'll get the same line as before. So either method is fine. Slope-intercept form or finding your x and y-intercept. Either way, you get 2 points to graph your line. And according to postulate 6, any line is at least 2 points. The second two lines we're going to graph are special. For y equals 4, you'll go to your y-axis and plot a point at 4, and it's always going to be a horizontal line. So I draw a horizontal line through y is 4. That way, no matter where you are on the line, you're always at y is 4. Similarly, for your x equals, you plot a point at x equals -3 and draw a vertical line. X equals equations are always vertical with an undefined slope. So no matter where you are, your x is always at -3. So this is x equals -3, and this was y equals 4. That concludes your lesson, or your review, rather, with graphing. Hope this is helpful. Feel free to rewind, pause, and to view this as many times as possible. Remember, after the first 1,000,000 views, I start to make 1/20th of a cent. No, I'm just kidding. All right, but I hope this was helpful. Enjoy the rest of your day.